Hello children, we are starting kinematics today. There are two chapters in it. First, this one, motion in a straight line, and the second, next one, motion in a plane. So what is kinematics? Kinematics is the branch of mechanics which deals with the motion of the objects without a reference to the forces that cause the motion. Means in kinematics, we will talk only about the motion of the objects, not the forces which cause the motion. When an object does not change its position as the time passes, we say that the object is at rest. And when the object changes its position as the time passes, we say that the object is in motion. However, there is nothing is in absolute rest or in absolute motion state. Everything depends on the reference frame. To understand the reference frame, let us see this example. Suppose a train is moving next to a platform. A person who is sitting inside the train will see its ceiling fan at rest. On the other hand, the person who is standing at the platform will see the ceiling fan as well as the other person moving. So we cannot say that the ceiling fan is at rest or in motion. The precise statement will be ceiling fan is at rest with respect to the train and ceiling fan is moving with respect to the ground or platform. Suppose there is a particle at point P. To locate this particle, we need a reference frame. A convenient reference frame will be three mutually perpendicular axes x, y and z in 3D Cartesian coordinate plane. Coordinates of this point will give the location of the particle. Now add a clock to this reference frame to measure time. As the time passes, if the coordinates of this point do not change, then the particle is at rest. If the coordinates means any of the coordinates x, y, z changes, then we say that the particle is in motion. Here onwards, we will assume that the reference frame is already chosen and the particle is moving with respect to the chosen reference frame. Now let us see translational motion. Translational motion can be defined as the motion in which all points of the moving body move uniformly either in same line or in same direction. Translational motion can be divided into two categories, rectilinear motion and curvilinear motion. In rectilinear motion, object moves in a straight line, means motion in 1D. Curvilinear motion can be divided into two categories, motion in 2 dimension or motion in 3 dimension, means motion in a plane or motion in a space. Now let us understand these terms. Distance, displacement vector, uniform speed or constant speed, non-uniform speed or variable speed, average speed and instantaneous speed. Suppose a particle is moving along this curve. This is our reference frame. Time taken by the particle is shown on the x-axis and distance it travels is shown on the y-axis. At a certain time t is equal to t1, it was at point A on the curve, and at t is equal to t2, it was at B on the curve. Then the distance it traveled between A to B is given by the length of this curved path. Displacement. Minimum distance between points A and B is called displacement. It is given by magnitude of this called AB. Displacement vector. Displacement is a vector quantity. Its direction is from start point to end point. So this is direction. Uniform speed or constant speed. Suppose the particle travels from point A to B on this curve at a certain speed. Its speed doesn't change. Then it is said to be uniform speed or constant speed. Non-uniform speed or variable speed. It is possible that during the journey, speed was changing. For example, suppose speed was v1 for a duration of delta t1, v2 for a duration of delta t2, and so on. Average speed calculation. Average speed can be calculated by the formula v is equal to, v average is equal to total distance traveled, let's say delta s, upon total time taken delta t. If the speed was uniform, this is the formula. If the speed was varying, then the formula will be V average is equal to V1 delta T1 plus V2 delta T2 plus and so on up to Vn delta Tn divided by total time taken delta t1 plus delta t2 plus and so on up to delta tn, and this is nothing but delta t. So the formula will be V average is equal to V1 delta t1 plus V2 delta t2 plus and so on up to Vn delta Tn upon delta T. Last one is instantaneous speed. Average speed is calculated for a duration of time, and instantaneous speed is calculated at a certain point of time. Suppose we have to calculate instantaneous speed at point P, then delta T has to be very small, means delta T tends to 0. So instantaneous speed will be equal to delta S upon delta T when delta T tends to 0, and this is equal to ds by dt. ds by dt is nothing but the slope of tangent at point P. Let us see these questions. First question, Arvind runs on a circular track of radius 14 meter. If he starts at one point and reaches at the same point, calculate the distance traveled and displacement. So this is a circular track. Let's say this is center O and this is one point A where Arvind starts running. This is 14 meter. So Arvind takes a round and comes back at the same point. So distance traveled will be given by the length of this circular path. And the length of the circular path means circumference will be equal to 2 pi into radius. Radius is 14. So it will be equal to 2 into 22 by 7 into 14. So 7 1s are 7, 7 2s are 14. 2 into 2 is 4 into 22, that is 88 meter. And the displacement we have to calculate. You know that the displacement is minimum distance between start point and end point. Since start and end points are same, so the displacement will be 0. Second question, a man walks at a speed of 4 km per hour for 1 km and 6 km per hour for next 1 km. What is his average speed for the walk of 2 km? So the average speed V average is equal to total distance traveled, that is 2 km, upon total time taken, that is T1 plus T2. We have to calculate T1 and T2. So T1 is equal to distance traveled 1 kilometer upon speed. So that is 1 upon 4 hours. And T2 is equal to distance traveled 1 kilometer upon speed 6 kilometer per hour. So this is 1 upon 6 hours. T1 plus T2 is equal to 1 by 4 plus 1 by 6. LCM is 12, 4 3s are 12 plus 6 2s are 12, that is 5 by 12 hours. Now V average is equal to 2 upon 5 by 12, and that is equal to 2 into 12 upon 1 into 5, that is equal to 24 upon 5, and that is equal to 4.8 kilometer per hour. Third question, the distance traveled by a particle in time t is given by s is equal to 2t square meter. Find its instantaneous speed at t is equal to 3 seconds. So instantaneous speed vi is equal to ds upon dt. That is equal to d upon dt of s is given as 2t square. We will take 2 out. So it will be 2 d by dt of t square. D by dt of t square is 2t. So it will be equal to 2 into 2t, and that is equal to 4t. So instantaneous speed is given by 4t. We have to calculate instantaneous speed at t is equal to 3. So put t is equal to 3. So Vi at 3 will be equal to 4 into 3. That is 12 meter per second. Now let us understand these terms: position vector, average velocity and instantaneous velocity. Consider a particle is moving along this curve PQR. This is the reference frame. Time taken is shown on the x-axis and position of the particle is shown on the y-axis. At t is equal to t1, particle was at point A, and at t is equal to t2, particle was at point B. When the position vector when the particle was at A is given by OA, let's say it is R1, and the position vector when the particle was at B is given by OB, let's say it is R2. Then the displacement vector AB is equal to vector R2 minus vector R1, and the average velocity will be given by V average is equal to R2 minus R1 divided by T2 minus T1, and it is equal to delta R upon delta T. Instantaneous velocity. Suppose we have to calculate instantaneous velocity at point Q. Then this time interval has to shrink, means delta T should tend to 0. Then instantaneous velocity Vi is equal to delta R upon delta T limit delta T tends to 0, and that is equal to dr upon dt. Now let us see these terms, average acceleration and instantaneous acceleration. Suppose the particle is having velocity v1 at t is equal to t1 and v2 at t is equal to t2. Then the average acceleration between t1 to t2 is given as v2 minus v1 upon t2 minus t1, and that is equal to delta v upon delta t. Instantaneous acceleration is given by delta v upon delta t when delta t tends to 0, and that is equal to dv upon dt. Now let us see motion in a straight line. First point is convention for positive and negative. If a particle is moving towards right or upwards, its direction of motion is supposed to be positive. Similarly, if it is moving towards left or downwards, its direction of motion is supposed to be negative. Second point, convention for motion. Generally, it is considered that particle is at origin at t is equal to 0, and then it starts moving along the positive x-axis. Third point, v is equal to dx by dt if the particle is moving along the x-axis, and a is equal to dv upon dt, which in turn is equal to d square x upon dt square. Similarly, integration of dx is equal to integration of v dt, and integration of dv is equal to integration of a dt. Let us consider these 2 points separately. Suppose we want a relation between x, v and a, that is position, velocity and acceleration. If we have to calculate the next quantity when the previous is given, then we have to differentiate. Suppose we want to get v when x is given, then we need to differentiate x with respect to time, means v is equal to dx upon dt and a is equal to dv upon dt. If we have to move in opposite direction, then we need to integrate, means to calculate v when a is given, v is equal to integration of a dt. To calculate x when v is given, x is equal to integration of v dt. Last point, direction of position, velocity and acceleration vectors. Consider a particle is moving in the positive x direction. Then its position vector and velocity vector will be in the same direction. Direction of acceleration vector will depend on whether the particle's velocity is increasing or decreasing. If it is increasing, then acceleration vector will also be in the same direction. But if particle's velocity is decreasing, then acceleration vector will be in opposite direction, means negative acceleration or retardation. Now let us consider motion with constant acceleration. Suppose a particle is moving with constant acceleration a. Then we can write dv upon dt is equal to a. That means rate of change of velocity is equal to acceleration. From here we can write dv is equal to a dt. Now integrating both the sides within limits. Initial velocity is v0 and final velocity is v. Initial time t is equal to 0 and final time t is equal to t. So we get this equation, v is equal to v0 plus at. This is first equation of motion in a straight line. Now write dx upon dt in place of v. So dx upon dt is equal to v0 plus at, or dx is equal to v0 plus at into dt. Now integrate both the sides within limits. Initial position is x0, final position is x. So we get this equation x equal to x0 plus v0t plus half at square. This is second equation of motion in a straight line. Now square both the sides of first equation. So we get v square is equal to v0 plus at whole square. We can expand this as v0 square plus 2v0 at plus a square t square, or v0 square plus take 2a common in both terms. So we will get v0t plus half at square in bracket. Now replace v0t plus half at square as x minus x0. So we get this equation v square equal to v0 square plus 2a x minus x0. This is third equation of motion in a straight line. You need to keep in mind these three equations of motion in a straight line. Just now we have seen that there are three equations of motion in a straight line with constant acceleration, and they are v is equal to v0 plus at, x equal to x0 plus v0t plus half at square, and v square is equal to v0 square plus 2a x minus x0. Now let us see equations of motion for free falling bodies near the Earth's surface. We know that the acceleration due to gravity works in the downward direction, and downward is supposed to be negative direction. So replace a with minus g. So the equations of motion for free falling bodies near the Earth's surface will be v is equal to v0 minus gt, x equal to x0 plus v0t minus half gt square, and v square is equal to v0 square minus 2g x minus x0. Let us see this question. Position of a particle x as a function of time t is given by x is equal to 2t square plus 3t plus 4. Find the velocity and acceleration of the particle when t is equal to 1 second. Means it is asking for instantaneous velocity and instantaneous acceleration. So instantaneous velocity vi is equal to dx upon dt. That is equal to d upon dt of x is given as 2t square plus 3t plus 4. So this will be equal to differentiation of this whole with respect to t is equal to 2 into 2t plus 3. That is equal to 4t plus 3. So instantaneous velocity is 4t plus 3. At time t is equal to 1 second, instantaneous velocity at 1 second will be equal to 4 into 1 plus 3, and that is equal to 4 into 1 is 4 plus 3 means 7 meter per second. Instantaneous acceleration. So instantaneous acceleration ai is equal to d by dt of vi. So that is equal to d by dt of vi we have calculated as 4t plus 3. That will come out to be 4. So instantaneous acceleration is constant throughout. So at t is equal to 1 second, it will be 4 meter per second square. Second question, a car starts moving with an acceleration 2 meter per second square for 10 seconds. Then it decelerates with 1 meter per second square. Find the total distance traveled by the car till it stops. Suppose car starts at A. It travels till B with acceleration 2 meter per second square and takes time t1, which is 10 seconds. From B to C, it decelerates at 1 meter per second square and takes time t2. Finally, at C, it stops. Its velocity at B is vb and at C it is vc. Vc is equal to 0. For section AB, v0 is equal to 0 because car was at rest at point A. A1 is equal to 2 meter per second square given. T1 is equal to 10 seconds given. So Vb is equal to V0 plus A1 T1. So Vb is equal to 0 plus 2 into 10. So Vb comes out to be 20 meter per second. Another formula, Vb square is equal to V0 square plus 2a into x minus x0, and x0 is equal to 0. So 20 square is equal to 0 plus 2 into a. A is 2 into x. So x comes out to be 100 meter. Means distance between A to B is 100 meters. Now for section B to C, Vc square is equal to Vb square plus 2a2 into x minus x0. For this section, x0 is 100 meters. So we will put x0 is equal to 100. Vc is equal to 0 because car finally stops. So 0 is equal to 20 square. Vb is 20, we have already calculated. So 20 square plus 2 into A2. A2 is equal to minus 1 because it decelerates. X minus 100. So x comes out to be 300 meter, which is the total distance between A to C. So the car travels 300 meters between A to C. Third question, a ball is dropped from a tower. In the last second of its motion, it travels a distance of 15 meters. Find the height of the tower given g is equal to 10 meters per second square. Suppose AC is the tower, its height is h. It takes t seconds for the ball to start from A and reach at C. So total journey time is t seconds. It is given that in last 1 second it travels 15 meter, means length of section AB is h minus 15, and it takes t minus 1 second to travel the distance AB. So now we will start forming the equations. For section AC, x equal to x0 plus u0t minus half gt square. Since ball is starting at A and going down, so x is equal to minus h. Minus h is equal to x0 is 0. Ball is starting from here. So x0 is 0 plus initial velocity u0 is also 0. Minus 1 by 2, g is given as 10 t square. So t square is equal to h upon 5. This is first equation. Now consider section AB. So applying the same equation again, minus h minus 15 is equal to 0 plus 0 minus 1 by 2 g into time is t minus 1 second for section AB. So t minus 1 whole square. So t minus 1 whole square is equal to h minus 15 upon 5. Now subtracting equation 2 from equation 1, it will be t square minus t minus 1 whole square is equal to h upon 5 minus h minus 15 upon 5. So t comes out to be 2 seconds, means total time of journey is 2 seconds. Put t is equal to 2 here in this equation. So 2 square is equal to 4 is equal to h by 5. So h comes out to be 20 meters, means the height of the tower is 20 meters. Now let us see motion with variable acceleration. When acceleration is a function of time, when acceleration is a function of position, and when acceleration is a function of velocity. Let us understand these with the help of this question. Find the formula for velocity v when acceleration a is given by a is equal to t plus 2, a is equal to 2x, and a is equal to 2v. Here acceleration is a function of time, here acceleration is a function of position, and here acceleration is a function of velocity. First part, we know that dv by dt is equal to a, means dv is equal to a dt. You need to remember this formula. Now integrating both the sides of it within limits. So integration of dv within limits v0 to v is equal to integration of a dt. A is given as t plus 2. So integration of t plus 2 dt within limits 0 to t. So v within limits v0 to v is equal to t square by 2 plus 2t within limits 0 to t. That means v is equal to v0 plus t square by 2 plus 2t. Second part, we know that a is equal to dv by dt and v is equal to dx by dt. So a upon v is equal to dv upon dx. Cross multiply v dv is equal to a dx. You need to remember this formula as well. Now integrate both the sides within limits. So integration of v dv within limits v0 to v is equal to integration of a is given as 2x. So integration of 2x dx within limits x0 to x. So that will give v square is equal to v0 square plus 2 times of x square minus x0 square, or v is equal to plus minus under root v0 square plus 2 times of x square minus x0 square. Third part, we know that dv is equal to a dt. So dv is equal to, put the value of a from here, 2v dt. Bring v on this side. So 1 upon v dv is equal to 2 dt. Now integrate both the sides within limits. Integration of 1 upon v dv within limits v0 to v is equal to integration of 2 dt within limits 0 to t. Integration of 1 upon v dv is equal to log v, that is natural log. Log v within limits v0 to v is equal to 2t. Now on the left hand side, we can write log v minus log v0, that is equal to 2t. Log m minus log n is log m upon n, means log v upon v0 on the base e is equal to 2t, or v upon v0 is equal to e to power 2t. So v is equal to v0 e to power 2t. Now let us see graphs. Xt graph, vt graph and at graph, means position time graph, velocity time graph and acceleration time graph when velocity is 0, when velocity is constant, when velocity is uniformly increasing and when velocity is uniformly decreasing. Xt graph when v is equal to 0 will be a straight line parallel to x-axis, and when v is equal to 0, velocity is 0, it will be a point, and acceleration is also 0, it will be a point. When v is equal to constant, xt graph will be like this slanting line, and vt graph will be like this, a straight line parallel to x-axis, and at graph will be a point. When v is uniformly increasing, it will be parabolic. Xt graph will be parabolic, and vt graph will be a straight line, slanting line, and at graph will be, this curve will be parallel to x-axis. V is uniformly increasing, means xt graph will be like this, and vt graph will be slanting like this, and at graph, in this case a will be negative, means retardation. Let us see xt graph, vt graph and at graph for uniformly accelerated motion and uniformly decelerated motion. Xt graph will be like this for uniformly accelerated motion, vt graph will be like this, and at graph will be like this parallel to x-axis. For uniformly decelerated motion, xt graph will be like this, vt graph will be like this, and at graph will be like this. It is on the negative side because it is decelerated motion, so acceleration will be negative. In the next video, we will solve previous year's JEE questions. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.